So data usage has increased 100 times over the past 15 years. And even more strikingly, more data has been created in the past 3 years than in all of human history. AI has forced the pace of progress. However, most notably, data centers have exploded in size in terms of power consumption. 10 years ago, a 30 megawatt data center was considered large. Today, a 200 megawatt facility is considered normal, which is pretty insane to think about. The driving force for this is the computing power required for AI workloads, which in turn bumps up energy consumption. According to research from the University of California, the amount of power needed for ChatGPT to generate a single 100-word email is 0.14 kilowatt hours, roughly equivalent to running about 14 LED light bulbs for an hour. In our current conversation with Dr. Benham Jafarpour of USC, in this episode, we had the opportunity to learn more about this.
Hi, Dr. Jafarpour. Thank you so much for joining us on this episode of the Energy Transition Podcast. We're so happy to have you here.
Oh, hi, good morning, and thanks for having me. It's a pleasure to be here.
So, Dr. Jafarpour, we want to start our conversation by learning a little bit more about you. Can you tell us a little bit about your career, your current role at USC, and about the work that you do in your lab?
Sure. I finished my graduate studies in 2008. I was a PhD student in civil and environmental engineering, looking at subsurface problems and trying to characterize flow and transport in subsurface systems with applications across energy and environment. And at the same time, I was trying to get a master's degree. I signed up to get a degree in electrical engineering at the same time, trying to see how we can use signal processing and image processing tools in order to help us better characterize subsurface systems. So that's how I got into subsurface energy and environmental applications. I had a 4-year position at Texas A&M before joining USC in 2011. And since I've been here, I've pretty much continued the line of research that I started as a PhD student, with broadening it toward different applications in subsurface, including conventional energy systems, geothermal reservoirs, more recently looking at CO2 storage systems. And my lab at USC is called Subsurface Energy and Environmental Systems Lab. And what we're really trying to do is leveraging different disciplines, mainly the system science, data science, and AI, and insight and understanding of subsurface flow, and trying to combine these in order to come up with innovative ways to characterize subsurface systems, their properties, try to predict the behavior of these energy and environmental systems at a larger scale, and try to optimize the performance. So we develop workflows for these type of applications. More recently, I would say since around 2016, we started a program on data science in my lab. We call that program Subsurface Energy Data Science. It's sponsored by a Canadian foundation called Energy, with an I at the end, Energy Simulation. And the idea there is to see how we can leverage recent development in deep learning, AI, and in general machine learning to advance the state of the art when it comes to subsurface modeling, prediction, and decision making. That has been basically our effort. I personally been in 3 different departments. My home department is in chemical engineering and material science, and I have joint appointments across electrical engineering and civil and environmental engineering. So that's in a nutshell, the background about me.
Wow, yeah, there's a lot of crossover of different engineering backgrounds and knowledge. That's incredible. Thank you.
Yeah, sure.
Yeah, Mila, that's an excellent point that a lot of this idea in data analytics isn't just sitting in computer science departments. It really is, what is the application in another department? And obviously, Dr. Jafarpour, you have to have a foot in both worlds or foot in several worlds as you do this. But I wanted to get the idea that, I mean, you mentioned AI, obviously. Everyone seems to be interested in that AI technology. Um, just to kind of borrow a quote that was talked about the internet is, it seems that the AI is an overnight success, but it's taken, advanced mathematics community nearly 80 years to get here. I mean, I'm not going to do a short history of AI, but you've got Max Newman and Alan Turing in England's Bletchley Park in World War II. In the University of Manchester, you got Eugene McCarthy at Princeton, Sebastian Thrun at Stanford and Google, and Sam Altman and Open AI and ChatGPT recently,
Yeah.
Justin Huang at NVIDIA, and even the 2024 Nobel Prize winner were AI pioneers, John Hopfield and Geoffrey Hinton. What's making AI such a high priority for everybody right now?
That's a very interesting observation. In fact, you're absolutely right. AI has been through its own boom and bust, and there have been different waves. The most recent one, however, starting around 2010-12, is really the convergence between multiple forces in play. As you mentioned, a lot of foundational work in academia and to some extent industry as well. There's a very rich history of AI, machine learning, neural networks. What has really enabled the recent breakthroughs is a convergence of the accelerated computing. We are all now familiar with the largest company on the planet in terms of market capital, which is NVIDIA, done amazing work in a short period of time in terms of advancing the computing power and computing technology. Add to that the revolution in data, the big data and all sorts of data that is being collected across the various disciplines. And this exponential growth in the amount of data that has become available across different disciplines, of course, it varies from field to field, and I'll get back to on that point to talk a little bit about the importance of data and how it differs from one field to another at a later point. And then the third one is deep learning. Deep learning in 2012. So neural networks had been there for a long time, but the performance of these systems had reached a plateau where in 2012 there was a very famous work of Geoffrey Hinton that showed that with increasing the amount of data that is used to train these models and um, uh, deepening these models, including more layers in neural network models, you can actually get significant performance improvement compared. There was a competition. There was a test data set, very popular one, ImageNet. This was a data set of about 1,000 objects, but around 1.2 million different images of those objects that were labeled. So the task was to basically see with what rate of accuracy different techniques can recognize objects in the pictures. And AlexNet was the model the deep learning model that Geoffrey Hinton and his student put together. And this model had about 60 million parameters in it. And it included about 650,000 neurons. which is compared to today, the standard is still not that large of a model, not that big. Um, but they showed that all they could outperform by a wide margin all the other existing methods, classical techniques, and they attributed that to the increase in the size of data that is used, as well as the number of layers they included in there, the number of parameters that they trained in their model. And everybody thought at the time or before that time that increasing the data and the model size would make these neural networks impractical and inefficient. But it just happens that basically that architecture, which was trained using GPUs at the time, two GPUs, that architecture, with the amount of data that was used and the power of the computing power that they had, was a demonstration that these things can be done much more efficiently if we actually go toward the use of GPUs for training them. And so these three, the advances in computing, the data revolution, and deep learning, combine that with the investment and real world application that since then we have experienced in AI and public engagement. These are aspects about the current wave of AI that have made it quite unique and quite impressive how much progress has been made in the past few years. And I think what is really amazing about the promise of these technologies is there is a hope that some of the big challenges and complex problems that we have, that with advances in AI and computing power and increase in data collection, we might be able to actually have some other breakthroughs in various fields. As you can see, if you look at different domains, you can't hardly find any domain that's not affected by AI. And the hope is that there's a lot more to come.
The addition of all those layers within that neural network framework, that's called deep learning, isn't it?
That's right. Yeah. So these are neural networks that have been there since 1980s, 70s, and they have had their success for a period of time, and then the performance plateaued until 2012, where they increased the number of layers, which meant that there are a lot more training parameters involved. Those are unknowns of these models that need to be trained using massive amounts of data. Naturally, when you increase the size of these models, you also need to include a lot more data to train them. So that's absolutely right. It's the increase in the number of layers, which means increase in the number of parameters that are trained.
Well, thanks. I think Mila's got a question that'll expand our, things beyond just the algorithms and the chips.
Sure.
Yeah, and before I ask that, I actually just want to ask, so when you say like the deep learning reaches its plateau, what does that mean? Like, does that mean it reaches its
I actually mentioned machine learning, the neural network, the standard neural network. They actually reached their plateau in terms of performance. What led to deep learning, which revolutionized basically the technology, was the increase in the number of layers to make these neural network models deep, and also the amount of data that was used to train them. All of that before GPUs came into kind of were used to train them. All of those was considered to be computationally very demanding, to the point that they may not become practical. But with the advent of GPU and their applications and the amount of progress we have seen in kind of increasing efficiency of these GPUs been astonishing. And now you can see we are talking about the AlexNet, which was in 2012, which is about 60 million parameters. ChatGPT-4 had 1.8 trillion parameters. So you can see how far we've come in terms of the size of these models, the amount of data that's being used to train them, and the computational power, right? That nowadays we put together to train these models. So there's been an amazing, amount of progress to witness.
Yeah, and as you mentioned, like with newer technologies, with the progress made with the GPUs, it seems like the parameters are increasing more and more every day. So when we use generative AI and these large language models, um, are we investing enough data in skills and critical thinking to support AI?
I think that's a very good question. I think when we think about the future and moving forward with the technology, computing power is one thing. The algorithm and architecture is, all of those are great, and there have been a lot of progress made. And but there are other things that we need to think about, and those are especially when we approach other fields, because every field has its own unique characteristics, and the conditions could be different from one field to another field in terms of data, in terms of skill sets that need to be developed within different disciplines, how to use AI, and also critical thinking, and what kind of applications, what kind of problems we want AI to solve for us, right? So that could change across fields. Um, for tech companies, of course, they have access to massive amounts of data, and they can use that data and train these models and for various applications that they have. But as you approach other fields, when you look into, for example, in the case of um, subsurface systems, right? In some applications, when it comes to science and engineering, data collection can be very costly, and it basically. But instead, we also do have a significant amount of knowledge that has been accumulated over the years about the properties of these systems that we deal with, what we call domain knowledge. There is a significant amount of domain knowledge. Now, the interesting question is, what are ways you can, in an innovative way, you can combine the advances in AI with the domain knowledge in various fields, and how you can approach these problems that we have in different fields in a way that not only we can address some of the specific questions that or challenges that we have, but in the future maybe even go beyond that and try to kind of rethink these problems and see what are the ways that AI can help us to actually have different way of thinking about problems and potentially finding newer and better solutions for some of these problems. So one aspect is really data, as you mentioned. And when it comes to data, it's not just the amount of data, it's also the quality of data. At the end of the day, we are training models based on the data, and the quality of the data has a direct impact on the quality of the modeling outcome or the model outputs. And then there are other aspects about platforms for data accessibility, as well as pre-processing, managing, sharing, all sorts of um, issues related to preparing the data in a format that can be readily used for training these AI models. And then the second aspect is really the skill set, developing these skill sets across various fields. And that's really of fundamental importance. And this has to be done across all levels of education, starting from post high school, community colleges, undergrads, and graduate school, of course, and being able to work across discipline. And that's really another important aspect related to the use of AI and how we can leverage AI to solve challenging problems that we have in different fields. And of course, another aspect of it is upskilling our workforce, people who are already in the workforce, and they need to be equipped with the skill sets that are needed to work to understand how these models work, and what are some of the fundamental properties they have, what are some of the potential challenges they may face in using them, and how they can best use these kind of tools in order to solve the problems that they face in their application area. So another aspect is really the computing platforms and computing infrastructure. A lot of large companies, tech companies in particular, they are building very large data centers and cloud computing resources. And it's really important to make sure that other smaller companies, government, universities also have access to these resources in order to be able to work on some of the challenging problems by leveraging AI.
Yeah, it's really interesting how you mentioned um, again, just having the cross-disciplinary knowledge, even within AI and, with the engineers that use it, especially with these modeling tools, it's got to know a lot. Thank you.
Yeah, yeah. No, I think it's being able to work across discipline is truly important. You can't expect computer scientists to come and solve problems for us in whether it's in energy area, in drug discovery, in autonomous driving, and all. Also, each application area, people in those fields have significant amount of knowledge about those systems that they're dealing with, and that knowledge is invaluable in terms of being able to actually build and develop the right AI models that integrate those knowledge with the data that is being collected. And without bringing that knowledge into the picture, you will basically have half of the story. The other half is really uh, being able to use understanding about this system to help us maximize the utility of AI in solving our problems.
Yeah, you
I
bring
think
a lot of great points. Thank you.
Sure.
your Dr. Jafarpour, your mention of the term integrate, I think, is one of the key topics with regard to this stuff. I mean, we got to be really impressed with how large models that we're building. Um, the kind of the reference was in training the OpenAI's Chat GPT 3.0. It ate the internet, right? So to train itself on what was becoming a generative AI sort of platform. But sometimes I worry we might be too naive in just natively believing the answer that comes from these tremendous correlation engines that we're building. Because engineers are really, at least we consider ourselves great problem solvers, right? But often they're kind of on a tactical, transactional, operational, sort of problem. But if your goals, as you have mentioned, is optimization and productivity and solving new, kind of challenges that previously we couldn't get anywhere near on. Are we asking the right questions of AI in your view? Is AI become is a tool, or is it now becoming kind of like a partner?
That's a very interesting way of posing it. And if you look at how AI is kind of progressing, it's really starting. It started as a tool to help us solve a specific problem. In fact, there are two different classes of AI problems. You have AI that is called a VKI or narrow AI, and then you have a strong AI. A VKI or narrow AI is referred to AI that is focused on solving a specific problem, and that's the typical use of AI as a tool. When you look at a strong AI, that's when we are expecting a machine to solve different problems, and that's what is known as artificial general intelligence. And if you go a step further, then you can talk about super intelligence, and that's when you expect that the ability of these AI machines to exceed the human intelligence. And that's when you were basically talking about AI now going from uh, being used as a tool to what you mentioned as a partner to work with us, collaborate with us to solve problems. And the first kind of wave of applications, and naturally that's how we are kind of wired in our training, is there are certain problems that we're focusing on in whatever systems we're dealing with. And our first attempt is to try to use AI to solve those. That's the application that is under the VKI, where we are either trying to optimize performance of the system, try to predict the behavior of the system based on some training, and deploying the model to give us predictions based on those correlations that it identifies from the data that's used for training. But the next kind of set of applications, and probably the more impactful use of AI would be now that we are going after these large models, foundational models, basically, to for various disciplines. Large language model is an example of that. Is now you can think of asking different kind of questions and trying to and it's not really easy. My own experience is that the way we've been through a lot of training to kind of learn a certain way of thinking about problems, and we had never interacted with the most we have interacted with people to solve a problem had been in teams and collaborations. But now you do have a massive kind of a very powerful tool that can potentially help you rethink your problem, and even allow you to kind of come up with new way of thinking about problems, because these new models will have access to a tremendous amount of data and computing power. They can run significant number of cases before they come up with or scenarios for modeling a phenomena, and come up with alternative solutions and analysis of pros and cons, and kind of helping us to even identify ways where we couldn't think of solving problems that way ourselves, right? So I think it's a very interesting concept, moving from a tool to a partner and learning how to interact with this partner. And there's a lot that currently is being done in this area, and the future potentially would be a future in which that we look at AI as a collaborator more than just a tool to solve a specific problem.
Well, we're going to have to be a lot nicer to our partner by feeding it good, trusted data, I think, in order to move forward. But uh, just you mentioned the idea of asking different questions, and I want to just pursue that for a second. I mean, if you're a reservoir engineer and you're trying to understand oil production, computational fluid dynamics. You were probably the leader in model building within your industry. You're using a lot of computer resources to do physics-based modeling. But now you mentioned you're also working on the environmental side, the sequestration side, the understanding of the methane emissions, all the rest. And since now we have a lot more data about those systems, um, do you think AI can help us ask the right questions, ask maybe new ones that we were kind of wired to think about from our physics-based world, and be able to make advances in those areas?
So it really depends on, these are questions that are very application specific. For instance, when we build models for subsurface, right? The general training has been that there's a vast body of knowledge in this field. You have an interdisciplinary team of geoscientists, geophysicists, and reservoir engineers, and they work together to integrate all the data that they have to build a model and simulate the behavior of the system, right? Now, the amount of data that you collect in this case is also uh, directly linked with the cost involved. And so we are in one of those applications, in this case related to subsurface, as collecting data can be very, very costly. So what AI can help us is how to collect data, where to collect data, when you have such a big cost for data collection. So our training mainly has been use these physics-based models, build them, use them to predict the behavior of this system. And then the data that's being collected while you're operating in these fields will be used to improve the quality of these models. So in a way, what we are used to right now is building physics-based models, or traditionally building physics-based model and using data to improve or update them. But AI application is a paradigm shift. And AI is actually developing a predictive model from data. And whether or not we have the right data sets or the amount of data to drive those kind of models, it's still a question given the cost that is involved in collecting data. Now, the other aspect of it that you referred to is whether we trust these models, right? And for a community that has spent over 100 years, learning about these systems and trying to model them, there could be some pushback in terms of using AI as a black box. That's what some people refer to it, where we don't know how these decisions are made, how these forecasts are made, and when the consequences can be significant of the decisions made from those forecasts. So that's where my point about being field specific and domain specific, you have to really look into the elements that are needed for AI to really pick up and be successful in that domain. Right now, the interesting area of work in our domain has been, how do you combine AI with physics? How do you bring the two together, leverage both of them, and try to come up with models that's not the same as what we had before, but have more influence from the algorithms that empower the AI machines, right? So it's very application dependent. In some other areas where, if you look at other, energy systems, that you don't spend a whole lot of money to collect data, then the data can help with all sorts of, prediction, decision making, and optimization of the performance of these systems. But there are areas where the cost of collecting data can be a big hurdle.
Yeah, you bring up a lot of incredible points about, the importance of the data with these models. It's like I think you brought up a wonderful point on like how, this industry going on like 100 years has, it has its path, it has its, system currently. So trying to introduce this, it's introducing just a whole other set of factors that need to be considered on top of everything else. So I thought you brought up a lot of great points. So with these data centers that are rapidly growing because, the power requirement is overwhelming for some of these utility capacities. Why are these hyperscaler data centers built for AI so power hungry?
Yeah, that's a great point. With the size of these models, the scale of these models that need to be trained, number of parameters that need to be trained, there is an intensive amount of computation and the computational requirements. And the large language model, as I mentioned, ChatGPT had over 1.7, 1.8 trillion parameters, and it took months to train those models. So what this means is that, those models were trained with thousands of GPUs. So what that means is that the amount of processes, computational operation that are needed to train this model is massive, and you can't simply do that without parallelization. And what does that involve? Parallelization is what GPUs are good at. Basically, the way they work is that you put together billions of these transistors in your GPU nodes and stack them on top of each other, and basically have massive amounts of data that are being processed by these GPUs over a long continuous period of time. And what that implies is that the amount of power that you have to provide for this system to do what it's supposed to do is going to be significant. And you probably have heard about the demand, the power demand that the recent statistics is about for 2023, it's somewhere between 2 to 3% of the total electricity in the US has gone to data centers. And for 2030, the estimates are about 90%. So they consume a lot of power because you are putting together a massive number of these compute units next to each other, a stack on top of each other, to go over significant amount of data, and that would require a lot of, by the way, matrix manipulation and operations that are done in parallel. And that's what leads to basically a significant increase in the demand of these GPUs for training these models.
Yeah, I can only imagine like how those models with these AI specific chips from companies, they could get so hot.
That's right. Yeah, that's another, implications of it. When you have to put, so one of the things that we try to also, and as part of the progress in kind of improving the efficiency of this system is making them smaller, right? Making them smaller and more powerful, and more density of them next to each other creates heating problems. where now you have to also not only provide the power to run them, but also figure out efficient ways to cool this system. Otherwise, they will have overheating issues, and they won't be operating at their optimal performance level. So that's another major issue, which is how do you deal with cooling and their technology, liquid cooling, and et cetera, that have been designed to deal with that aspect. That also consumes a lot of power. So those are really important uh, contributions to the demand in power. And what tech companies have gone after, because these models are run for a continuous amount, like long amount of time continuously, which means you need to have reliable source of power at that level. And then as the size of these model keeps growing, your demand for power is going to grow. And what that means is that the expansion by public utility companies would not be there to support the kind of power increase that we're asking for. And the solution from some of the big tech companies has been to go after their own way of their own kind of independent and private kind of power sources, looking into nuclear options, looking into geothermal, and at the same time, these companies are very sensitive to climate issues, and they also don't want to, have an impact on the environment. So you can see some of the solutions that they're trying to come up with in terms of both reliability, efficiency, cost, and environmental implication is to really try to figure out solutions that they can rely on for moving forward with their AI ambitions.
Yeah, I think you brought up a lot of great points. It's going to be interesting to see like as AI, keeps growing with these big tech companies, um how the big tech companies balance the power demand with, with sustainability, especially when the power demand is so large.
Absolutely. That's one of the challenges that they're facing, and they're trying to kind of go after solutions that they previously didn't had in mind. And chances are that the demand is going to just go up.
Well, I saw when we were talking about been at this for 100 years. Mila looked at me, and I promise you, I haven't been around for all of those 100 years, but a pretty good chunk of them. And I can remember, um, you know, coding in Fortran on my signal processing theory based seismic application on punch cards. And if you're talking about I have 1.7 trillion data elements, I think I would wear out the punch card machine before I got my job put together. So, it clearly is a paradigm shift that you mentioned. I mean, that's dead on. Um, I even read now where the servers are getting so hot. You mentioned the cooling issue, that maybe the forced air cooling systems that we use today aren't going to be good enough. We're going to have to give our partner a bath. We're going to have to put the servers actually in liquid in order to try to keep them cooled so they can do all of this. So it's a paradigm change for data center architecture as well.
And you know what is interesting is that what the CEO of NVIDIA, Jensen Huang, sometimes talks about is that um, for a lot of these problems, AI might help us find solutions, which is interesting, right? The problem of addressing an issue that AI is causing through AI. And I think it's a very interesting perspective. In fact, it's not just that. It's even in the design of these chips, AI is involved. So it's pretty amazing how this thing you know uh, can help even its own design or
Yeah,
design of
that's
elements
a
of it.
great point about building on each other. I mean, a lot of times when today when you talk to a tech guy and they don't really know what the answer is. They said, well, AI will solve it. Maybe that's the truth. Maybe in all of these new challenges in the energy transition, whether it's system optimization or different reimagining ways of doing things or doing all the rest of that. Yes, AI is a increasing demand on our energy systems we have to accommodate for, but maybe AI is also the way we're going to solve those problems. Do you think
That,
that's true?
that's a great point. I think one of the amazing things about AI is that we really don't know what it's capable of, right? We don't really know what, it's one of those technologies that, if you look at internet, if you look at some other technologies that we had, people had some predictions about where it can go, right? AI is a very different kind of concept, right? It's very hard to predict what it can do, right? At some point, whether that saying that you just mentioned about AI will solve it, we really don't know. It might, right? Nobody can give you the answer to that. But I think but certainly we are not there yet. But what's also important here is really the approach we take with AI. And I think at least what I notice in my own students is that there's this tendency to take AI and apply it, in any problem they're dealing with. But I think that, in my head at least, the right way of approaching our problems in our specific domains is to look at what are the challenges and then try to see how, if we have an understanding about AI, if we have an understanding about the fundamentals behind it, then we would be in a good position to see whether and how AI can help solve our problem. So that's this aspect of it is really the immediate application of AI in different domains, right? Then there is the second part, which is trying to kind of take a step back and rethink the problems, trying to kind of not look at a specific task that needs to be completed, but looking at it more as maybe there's another way that I cannot think of. We might increasingly go in that direction. It's not easy because of the way we are wired, but that goes back to AI as a partner versus AI as a tool. I think that's also an interesting aspect, which involves really us trying to reimagine our problems and not just think of AI as a tool that we can just borrow and apply to our problems. I certainly myself discourage my students from just taking AI and applying it. I want them to learn about AI, but I want them to couple that with their own understanding of the problem, their own knowledge about the problem, with an open mind, of course, and see how they can integrate both sides, the domain knowledge and the AI to solve the problems that they're dealing with. But again, those are very early applications. They're very specific tasks. I think what future holds is really AI as a partner and how AI can help us solve some of the big challenges we have, from climate change to drug discovery to autonomous driving. So all of those problems are at some point they were thought of as incredible challenges, but even now some of them are among our grand challenges, and AI might provide significant breakthroughs at some point in solving those problems.
In the 1950s, Alan Turing was thinking about the question, what makes a machine intelligent? And so he came up with his Turing test with regard to that. And I think, Siri has been passing that Turing test for a long time now.
Sure.
So we are already interacting with AI enhanced search engine sort of things already,
Right.
and we better start using it as a treating it as that partner, but with the critical skills that of the domain knowledge that you pointed out.
Absolutely.
Mila, turn it over to you to close this out.
All right. Well, Dr. Jafarpour, thank you so much for your time today. It's been a real honor to have you on this podcast. But before we leave, is there anything that we forgot to ask you that you think is important to share with our audience?
Oh, first of all, thank you for having me. It was a pleasure. I really enjoyed our conversation. And I think that as a faculty in academia, what I want to close with is really the importance of education and enabling the next generation to think differently and the training that is needed in order to enable them to do that. And the importance of having them involved early on in cross-disciplinary uh, education, research, and whatever they're interested in. And AI really needs to be part of the education. And, who knows 10, 20 years down the road where AI would be. But definitely, with the amount of attention, with the amount of investment that has gone into it, you can see that even across many universities, the syllabus, the curriculum that they put together, um, they, including USC, they're significantly revising those in order to introduce elements of AI and its application in various domains. But it's really important to have the students involved in and at least get some basic understanding of AI and equipping them with the tools that they need. This is an important tool. At some point, maybe a partner, but it's important to know how it works. Not to the level of detail, required at the research level, but at the very basic level, how these things work. I've been amazed sometimes when I go to various conferences and meetings, and people talk a lot about AI, but including students, they talk a lot about AI, but in terms of understanding, the fundamentals, what's under the hood, I think that's an area where we need to work on with our students and encouraging them um, to not only learn that aspect, the AI tools that are available, that what are the properties of those, what are some of the weaknesses, some of the strengths, um, but also how they can be leveraged in their own problems, and also this ability in them to ask questions, even from professors, or why are things the way they are? Why are we thinking about problems the way we're thinking about the problems? And what are other possibilities? And this is really a challenge for myself too, in terms of changing the way I think about the problems. It's just the way we are used to thinking about problems, and recent progress in AI has shown that the future could be a future in which AI can help us think better and give us alternatives that we may not be able to think about ourselves. And I think the importance of education cannot be, overstated. And students, need to really have at least a basic understanding. And I'm glad to see the progress and what we've done at USC also with the School of Advanced Computing. That was a great initiative, great investment that USC made, and next generation of the students will bear the fruit of that.
Well, again, thank you so much, Dr. Jafarpour. A decade or so ago, I coined the term the digital engineer. But I was thinking about, making sure you don't forget your physics, but also learn, remember a lot more of the statistics that you took a class in, but you really didn't like very much. but now it's a whole different ballgame. I mean, right? AI as a partner is another step forward, as you said, from the digital engineer. I gotta come up with a new a new buzzword because right now, as you said, everybody uses the term AI, whether they have any idea what they're talking about or not. But we need to understand what it can do, what it can't do, what it'll only kind of respond to the data that we feed it to train the model. All of these sort of things have to become a new paradigm in approaching problems and having this significant computational capability, even if it does burn a lot of energy, um,
Right.
to be our tool, to be our partner, maybe even in some cases to be our guide. So thank you so
Absolutely.
much for your insight. I appreciate that.
Sure. Thank you. Thanks for having me again.
Dr. Jafarpour's lab is called Subsurface Engineering and Environmental Systems Lab, leveraging systems science, data science, and AI to characterize subsurface systems.
We talk about the recent boom in AI due to convergence of computing power, which is the use of GPUs, the big data revolution, and deep learning, which is increasing the number of layers in the artificial neural networks.
And as we heard, every field has its own characteristics and its own specific data issues, and the importance of critical thinking about useful applications.
Dr. Jafarpour said the key is to combine the advances in AI with domain knowledge.
It's not just the amount of data, but also the quality of data.
Being able to work across different disciplines is becoming more and more important, and understanding the AI model is only half the story.
Is AI just a tool to solve a specific problem, or is it becoming a partner, like generative AI?
Collecting data can be very costly, but we can use AI to process a lot more of different kinds of data to build a predictive model from the data itself.
What will it take for us to trust the results from models generated by AI?
The new AI hyperscaler data centers are incredibly energy hungry. We talked about the 30 megawatt centers about like 5, 10 years ago, but now they're in the 1 gigawatt scale, and they cost about 3% of the U.S. electricity in 2023, and it estimates it's going to turn to about 9% of energy consumption in 2030. It's not only to power the large number of chips, which is what many people usually think, but it's also about cooling them down.
We don't really know what AI will be capable of.
And with AI, we have a chance to reimagine all of our problems.
The geothermal industry is quietly experiencing a renaissance, emerging as a crucial player in the global transition towards sustainable energy. As the demand for clean, reliable, and sustainable energy grows, geothermal energy is gaining attention, not only for its low carbon footprint, but for its potential to provide consistent 24/7 power.
I've heard of the Geysers geothermal power plant in Northern California where I live, but I didn't know that geothermal energy can play a huge, significant part of the energy transition in other parts of the country.
In this episode, we are fortunate to be able to talk to several experts in this energy sector, including John Clegg of Hefe Energy in the UK, and Dr. Will Fleckenstein of the Colorado School of Mines, and the CEO of a new startup using enhanced geothermal systems technology.
It's great to know that under the new renewable energy category, it's more than just wind and solar. Using the all of the above energy source portfolio, including geothermal, hydroelectric, and nuclear, maybe someday hydrogen can give us a lot more options.
I got involved with oil and gas and energy through my father, and he actually told me about how the energy transition started. He one time told me when he was working on a farm in Kansas when he was a little kid that the day that they got their first tractor, where they actually transitioned from using draft animals to mechanization, which was really kind of a amazing type of a thing to think of, is to try and do all the things you do on a farm, but with draft animals, horses and oxen. And so my dad had worked in the oil industry. He was had grown up during the Great Depression. Kind of rode the rails a little bit, going to try and play baseball, et cetera, and then went to went into World War II, and he worked for a company that built drilling rigs, and that was kind of how I kind of started understanding how you drill oil wells and produced wells, and so that was one of the drivers for me, was just understanding and then kind of taking things a little bit farther past where my father was. And so if I could talk just a little bit further. So then I came to the School of Mines, got my undergraduate degree and my master's in 1981. When I started at the school, there were 4,500 drilling rigs that were drilling vertical wells in the United States. They really weren't keeping production up, but a lot of drilling was going on. Then I got out of school with a master's degree, and the first job I had was actually working as a roughneck because the price of oil had dropped very dramatically. There were no jobs out there. The joke used to be if you wanted a petroleum engineer, you would ask for a waiter. So I started working by the Salton Sea as a roughneck on geothermal wells, and immediately started to see, both the opportunity as you're producing the 650-degree water, but also the difficulty, all the scaling, all the corrosion that went on with it, et cetera. So then I transitioned into oil and gas. I became a drilling supervisor at a place called the Elk Hills Naval Petroleum Reserve. I worked out there for about 7 years, mainly in drilling and completions, before I came back to school to work on my doctorate and continue. So the first thing we did was I'd gotten a grant from the Department of Energy for $5.3 million to develop the tools and technology for what is called conformance control for enhanced geothermal systems. And then based upon that, I was able to get a patent for the system for conformance control. It's essentially the only patented conformance control system that's on the market. One thing somebody told me early on was that you can't sell a technical paper, but you can sell a patent. And so as soon as we actually had patented the technology, that's when we were able to attract some interest from the investment community. And we now have a $5.5 million seed round that is contingent on several milestones as we're going forward, of which we've gotten the first $1.7 million tranche just a few months ago.
Could you explain a little bit on sort of a high level what conformance control is?
I beg your pardon?
Could you explain on a high level what your technology is and what it does?
Sure. So enhanced geothermal systems in concept is very simple. You pump cool water into the subsurface, it heats up, you produce it to a power plant, and you get this carbon-free energy. The problem is, how do you make the water go where the heat is at in the subsurface? And so what our technology allows you to do is to first construct between two horizontal wells or a series of horizontal wells, this matrix of fractures that then you have to, where the water travels between the injectors to the producers to harvest heat. And what our technology does is allow you to first construct that by creating these hydraulic fractures for the construction of the subsurface heat exchanger, but then also like a radiator to make sure that you can control where the water goes to uniformly harvest the heat, regardless of what the size of the fractures are, because nature is not symmetrical.
Thank you so much for joining us for the Future of Energy. Special thanks to each of our guests today and to our technical wizard, Abhi, for his important contributions to this episode. Don't forget to subscribe to our podcast so you can automatically get access to all our new episodes. You can find us on Apple, Spotify, YouTube, or wherever you get your podcasts.